Okay, welcome to part two. Now, as you can see the screen, we're gonna take on looking at more captures. This is Honda idle speed control with math channels and duty cycle. As you can see your screen, that's a still shot from where the other video, the part one ended. You can see the math channel, the speed of math channel in magenta, and you can see the black math channel is a duty cycle based off channel B. And the magenta is based off of channel orange. Just so you know, that is a crank sensor on orange. Really, that's a thick looking, you can't granulate in there. I mean, but the math channel depicts what's going on in that, at least the RPM math channel depicts what's going on in that orange signal. So here we go. We're gonna look at the next phase of the video. We're gonna look more of situations with the idle speed control, and we'll talk about it. Shot on the 31st. Okay. Okay. I'm going to call this one, this is power steering pressure side to side. So look at your schematic, you see the power steering pressure switch. It will be opening and closing as I'm idling. You can take a look at the channel in green. The green channel is the voltage change, and it's pretty obvious on the scope. You can see when the voltage is low, that's when the power steering is straight ahead. So it's a normally open switch. If the steering wheel is straight ahead, we're going to see 12 volts at the PCM with that switch being open, and 12 volts comes from the PCM, and it doesn't flow any current through the power steering pressure switch to ground. Okay, at the moment that the power steering pressure switch closes, that's when current flows. And guess what? I'm giving you bad information. I apologize. Let me get my faculties here. Okay? The power steering pressure switch is normally closed. And when the... oh, Jesus Christ. Oh, my God. Ah, screw it. Let's move forward. Come on. Let me get my faculties here. Okay. All right. Been a crazy day here. Let's just look at the circuit and be logical about it. Look at the power steering pressure switch. It's either on or it's off. It's got 12 volts pushing against it from the PCM. So when the power steering pressure is in a straight ahead position, the switch is open. Okay? Oh my God, I'm getting a brain cramp. This is really embarrassing. I gotta get my, you know, just bear with me. Jesus Christ. I had this down perfect. Let's look at the logic in here. Well, let's make a math channel and and see where the duty cycle changed. All right, we'll do it that way. And let's go to the duty cycle and see where the duty cycle changed. Okay, all righty, here's our duty cycle. All right, so let me kind of figure out my own dilemma that I created. This is remember I said the duty cycle would be, let's look at just like this point right here, because this is the point where the state changed. We went from 12 volts to a low voltage. So with 12 volts here, that means the power steering pressure switch is open. So that means the switch is open, and then here's where the switch closes. All right? So, oh my God, I'm just feeling stupid. This is embarrassing. I gotta pull myself through. Come on. All right. Disconnect the power steering pressure switch. What I do in a future scope, I'll show you. When I disconnect the power steering pressure switch, idle goes up. So an open power steering pressure switch would be tantamount to a load. So a closed power steering pressure switch is when the steering wheel's straight ahead. So the steering wheel's straight ahead. Let's look at this. So this is when the steering wheel's straight ahead, right here. This is when I'm turning the steering wheel, and oh God, I'm so bad under pressure. This is so embarrassing. I gotta get this. I gotta just complete this thing. I just got so much on my mind. Come on. All right. All right. Power steering pressure switch. Will open when a power steering pressure switch opens. That would indicate it's the PCM is sensing a load of the power steering, and that's when the voltage is high. So when the voltage is low, the switch is closed, and we have microamps flowing through the circuit. We have a closed circuit at the power steering pressure switch. Right here, that's red. That is that micro clamp, and that I filtered it basically. Here it is in red. Okay, you can see that in red right here. That's this guy here. That is current. That means current's flowing through the power steering pressure switch to ground. Okay, and our duty cycle is decreasing because we got to think opposite on this. So our duty cycle would be decreasing, and that would indicate that the steering wheel is straight ahead. Okay, right here is when the steering wheel turns hard right, hard left, and the power steering pump gets loaded, and the idle RPM has to go up. That's when the power steering pressure switch opens, and it goes to 12 volts. Our duty cycle goes. What happens to our duty cycle? It changes. It goes. It goes high. That this would indicate it's opposite. It's going high, and the RPM is gonna. Let's look at this in the blue. And as we can see something here, the distance from here to here, and the distance here. I hope you guys with the naked eye you can see that this one. Okay, this guy is longer than this guy. That would mean we're raising the idle speed to adjust for the load. So basically the duty cycle is doing the opposite. When I say it's going down, it's really going up. That's when this power steering pressure switch is open and there's no current flowing. That would indicate a load, and hence the PCM would have to jack the duty cycle. Okay, I'm gonna make things a little more complicated before I end this crazy video. This is part 2, which I hope I'm a little more stable in part 3, but here we go. I'm gonna bring the RPM math channel in, and here we go. And let me take a look. Frequency D. No, I don't want that one because that has too much range. Let me try this one. Frequency D. Okay, I'll try this one. Okay, this is no, that's not working. Get that. Math channels. Oh no, that's what I did. I did 2 duty cycles. That was stupid. Have a frequency D. Here we go. Okay, now you can see it. All right, now you can see, remember, as I showed in the first video, the magenta is the speed, the engine speed, which comes from frequency off the reluctor wheel, the crank, where the crank sensor gets its signal. Okay, we can see swing now. Okay, I'm going to stretch that, and then we'll kind of get an idea of what's happening here. That's magenta. I'll put that in front. And you can see this right here. You see, okay, you can see the relationship. Everything's tied together. You know, the duty cycle, the inputs, the outputs, the power steering pressure switch, the current flowing through it, the voltage change, the duty cycle in blue, and the RPM in orange, which have become math channels. And you can see the swing in magenta. That's the RPM changing, going here. Then there's another swing right here with the duty cycle and the RPM change. And you can see it right here. There's our duty cycle, and there's our RPM change in the magenta. So anyway, that was a little rough, but that'll be part 2. Part 3 is going to show you some more stuff. But now we're getting acclimated with math, with multiple math channels and inputs and outputs. So just bear in mind, the math channel for the duty cycle is going to be opposite. As it goes down, that really means the percentage, if we had a duty cycle meter on it, would be going up, and more air would be getting past the throttle plate to make the RPM go up. And as you can see, here's our RPM swing up and down, and RPM up and then down here. So anyway, that's part 2, and I'm coming back with part 3. Thanks.